This video goes over solving trig identities. And so really trig identities are writing trig ratios in terms of one another. And they're all based on this idea that a point on the terminal arm of an angle we can represent as xy, which gives us our opposite side, our adjacent side, and our hypotenuse. So what we can do here is we can represent sine as our, let's relabel these appropriately, as our opposite over hypotenuse, cosine as our adjacent over hypotenuse, and then tan as our opposite over adjacent. Now the first type of identities that we have are the reciprocal trig ratios. So cosecant is 1 over sine theta, secant is 1 over cos theta, cotangent is 1 over tan theta, and just as an add-on, tan theta is also equal to sine theta over cos theta, which means that cotan is equal to cosine theta over sine theta, and we'll see that down below. So let's simplify each of these trig expressions using those three parameters that we have, x, y, and r. So sine theta, I know, is y over r. Cos theta, I know, is x over r. So rewriting that as a division statement, I've got y over r divided by x over r. Now I can invert and multiply. Canceling out the r's leaves me with y over x, which I know is equal to tan theta. This is called the quotient identity. And the next one we're going to look at is called the Pythagorean identity. So I'm going to start by replacing sine theta with y over r all squared, and then cos theta with x over r all squared. Now applying that squared, I get y squared over r squared plus x squared over r squared, and then I can add the numerator together because I have a common denominator. Going back to my triangle that I drew up here, because of the Pythagorean theorem, x squared plus y squared is actually equal to r squared, which means that sine squared theta plus cos squared theta is actually equal to 1. And this is called the Pythagorean identity. So we use these identities, the reciprocal trig ratios, the quotient identity, and the Pythagorean identity, to actually prove more complex identities or more trigonometric relationships. So how do we do this? We separate the sides. We work through one side to make it equal to the other side, which is our goal. So let's start here. We've got our left side and our right side. It is important to separate them because we are trying to prove that they are equal. We don't want to assume that they are equal at the beginning. So my strategy here is I'm going to write everything in terms of sine or cos, no more tan. So let's do some rewriting here. I know that tan x is the same as sine x over cos x, and I've got sine x on the bottom. Cos x multiplied by sine x over cos x is just sine x. Now I'm left with sine x over sine x, which just equals 1, which is equal to my right side. So then I've proven my identity. The left side equals the right side. Cos x tan x over sine x is equal to 1. Let's look at another example. Here we've got sine x tan x equals cos x tan squared x. So again, I'm going to separate my sides because I'm not assuming that they're equal. And this one here, I am probably going to have to work on both sides to get them equal to each other. I don't really need these equal signs here. Okay, so let's start on the left side. I am going to replace tan x with sine x over cos x. So what that means is now on the left side, I've got sine squared x over cos squared x. So that's fine. I'm going to leave that where it is. And now I'm going to do some work on the right-hand side. So I've got cos x here. And then I'm going to replace tan squared x with sine x over cos x all squared. So that's fine. So let's keep going. Here I've got cos x times sine squared x over cos squared x. But look at that. I can use my knowledge of powers to say that I'm left with only one cos x on the bottom. And I've got sine squared x over cos x on the top. Now my two sides are equal. So my left side is equal to the right side. Therefore, my identity is true. So let's try another example here. We'll do two more. So the next one, now I've got 1 plus cotan squared theta equals cosecant squared theta. Okay, so let's think about what I'm going to do here. First thing I'm going to do is I'm going to split my sides, left side, right side. So I've got 1 plus cotan squared theta, and then I've got cosecant squared theta, which are my reciprocal trig identities. Okay, so let's start with my left-hand side. I've got two terms. If I can get that down to one term, that would be great. So let's start with replacing cotan squared theta and rewriting it in terms of sine and cos. I know from above that this is equal to cos squared theta over sine squared theta. Okay, so I've got two terms here, but I know how to add fractions. I need a common denominator. So I can find that here. So that means I would have sine squared theta over sine squared theta plus cos squared theta over sine squared theta. Adding those numerators together, now I've got sine squared theta plus cos squared theta all over sine squared theta. Recalling my Pythagorean identity, I know that this is equal to 1 over sine squared theta. What I know about cosecant squared theta is that this is actually 1 over sine theta because of my reciprocal trig identities. So that means that my left side is equal to my right side. I've shown my identity is true. So 1 plus cotan squared theta is equal to cosecant squared theta here. Let's do one more example. Lots of squareds here. I've got tan squared x, cos squared x equals 1 minus cos squared x. So first thing I'm going to do is split up my sides. I've got my left side and my right side. Here I've got tan squared x, cos squared x, and then on right hand side I've got 1 minus cos squared x. Okay. So what do I know about the right hand side here? Well, I know that 1 minus cos squared x is actually going to be equal to sine squared x because of the Pythagorean theorem identity. So let's see if I can do some work on the left-hand side to get that to be equivalent. Tan x is equal to sine x over cos x. We know that. So tan squared x is actually going to be sine squared x over cos squared x, and then I'm multiplying by cos squared x. Now my knowledge of powers says that I can cancel those out, which means that I'm left with sine squared x over here. Now I've got the left side equals the right side, which means that I've proven my identity. Tan squared x, cos squared x equals 1 minus cos squared x, and then I'm done. Those are some examples of proving trig identities using the reciprocal trig ratios, the quotient identity, and the Pythagorean theorem identity.